This is a weekly summary of interesting news that is relevant for my distributed systems lecture at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Boczek, and today we will discuss 6 topics. The first topic is how Netflix uses Java. It's the following YouTube video here. Netflix uses Java extensively for its backend systems that power its streaming and studio operations. Their architecture is built around a federated GraphQL system where a single GraphQL request from a device triggers multiple backend services. For streaming services, Netflix handles extremely high request volumes across 4 Amazon regions worldwide to maintain low latency. Their architecture features extensive microservice fan-out with aggressive timeouts and retry mechanisms to manage failures. For caching, they primarily use in-memory distributed data stores. While Netflix architecture uses GraphQL for UI to backend communication, for service-to-service communication they use gRPC, and the backend services run on Spring Boot. Netflix recently incorporated virtual threads from newer Java versions to improve parallel processing capabilities without the complexity of reactive programming, allowing developers to write simpler code that still performs efficiently at scale. And those are interesting details in this video from Netflix that have built a massive distributed system. Very interesting YouTube video here. The next topic is about SQLite multi-tenancy. It's the following article here. SQLite supports a powerful one database per tenant pattern for web applications, and this article is about this pattern, and this approach places each tenant's data in its own separate database file, providing strong isolation between tenants. While many large systems use sharding within a massive database, the SQLite approach moves in the opposite direction, embracing tiny data with many small databases instead of few large ones. This pattern offers several advantages: simplified debugging, easier backups using simple rsync commands, and natural isolation, preventing cross-tenant data leaks. And of course, the author didn't mention that explicitly, but you have also some drawbacks. For example, new features to roll out that requires database changes are more complex with many tiny databases. But what sparked my interest was not how the author did it, but how easy multi-tenancy sharding can be implemented in SQLite since it's based on file. The author then shows how to use active records for SQLite multi-tenancy with Rails, but my main point is that sharding solution can be quite easy, and the author describes this approach here. The next topic is why distributed systems are important. It's about the blackout in Spain and in Portugal. On April 28th, 2025, Spain and Portugal experienced massive power outages affecting millions of people. The blackout was caused by 2 disconnection events in the electric grid, with officials ruling out cyber attacks as the cause. Both Spanish Prime Minister and the Portuguese Prime Minister have promised investigations, with Portugal requesting an independent audit from an EU agency. And the latest news from yesterday is that they're still investigating. It's the following article here. So they have teamed up, Spain and Portugal teamed up to investigate this power outage. And the current state is that the Red Eléctrica de España, in short REE, has pointed to 2 closely timed incidents occurring just 1.5 seconds apart as potential culprits. One of these may have affected solar energy production in the southwest region of Spain, though further analysis is needed. So it's still not clear what caused this outage. While power has been fully restored, the impact was significant. People were stranded in trains for hours, businesses had to operate by candlelight, and normal services were disrupted across both countries. Spanish officials have promised to implement all necessary measures to prevent similar failures in future. Well, first they need to figure out what caused it and then fix it. But this incident perfectly illustrates a key point from our distributed systems lecture. Hardware will eventually fail, no matter how well engineered. Physical systems have vulnerabilities. Organizations with distributed system architectures spanning multiple countries would have maintained operations during this regional outage, demonstrating why geographical distribution of critical systems is essential for resistance against infrastructure failures. The next article is about Gen AI. It's the following article here. Recent research from economists at the University of Chicago and University of Copenhagen examined how Gen AI tools like ChatGPT, Claude, and Gemini affected 11 occupations considered to be disrupted by AI, including accountants, journalists, software developers, and teachers. And since I'm a software developer and teacher, I'm curious what they found out. Well, despite widespread adoption of these tools across industries, the economists found that generative AI has had no significant impact on earnings or recorded hours in any occupation. Interestingly, AI is creating new tasks, including those who don't use the tools themselves. Teachers now spend time detecting AI-generated homework, while others review AI output or craft effective prompts, essentially canceling out potential productivity gains. So AI is creating new work that cancels out some potential time savings from using AI in the first place. I won't go into specific numbers as other studies show different numbers, but I think that being more productive with Gen AI tools will result in more work. You will be able to achieve more, but this also means more work. And the researchers here concluded that my general conclusion is that any story that you want to tell about these tools, behind every transformative needs to contend with the fact that at least 2 years after the introduction of AI chatbots, they've not made a difference for economic outcomes. That's interesting. As I mentioned, other studies have other numbers. Probably it's too early to tell what the effects will be, but I believe it will produce even more work. The next topic is a topic that we will discuss in the blockchain lecture. It's the following article here. It's about Bloom filters. Bloom filters are probabilistic data structures designed for efficient set membership testing. Created by Burton Bloom in 1970, they provide a way to quickly determine if an item is definitely not in a set with a small probability of false positives. This space-efficient structure works by using multiple hash functions to set bits in an array. When inserting an item, it's hashed k times, and the corresponding bits are set to 1. When testing membership, if any of these bits are set to 0, the item is definitely not in the set. If all bits are set to 1, the item is probably in the set. And the author shows how Bloom filters work, and I also want to point out another site that also has an interesting visualization for Bloom filters. It's the following here. So you can have here your array and the number of hash functions. Here you can enter some items, and then you see here which bits are set to 1, and then you can also test for membership, test 1, 2, 3. I have not entered yet, so search. It's definitely doesn't exist, but if I search here for only tests which I added, then it will say it may exist in the set. So there's a probability that it may be in the set. What makes Bloom filters so powerful is their constant time lookups regardless of the number of stored items. For applications where disk access is expensive and most membership tests return negative, Bloom filters significantly improve performance. And here he has a practical example. 1.2 gigabyte Bloom filter can represent 1 billion items with just a 1% false positive rate, with lookups taking only 80 nanoseconds. And the author used Go for the benchmarks. And we will be discussing Bloom filters in the fall semester. The last topic is about JJ, a version control system that can work on top of Git. It's the following site here. Jujitsu, in short, JJ, is a modern version control system that challenges traditional Git workflows by treating code history as a flexible collection of changes rather than rigid commits. While still using Git storage under the hood, JJ's approach provides great safety and flexibility for developers. The core innovation in JJ is how it automatically captures every edit you make to your working files, unlike Git, where you must explicitly commit changes. JJ continuously tracks modifications as part of your current change. This eliminates the need for staging areas, stashing, and worrying about uncommitted work being lost when switching between different parts of your repository. JJ introduces powerful capabilities like the operation log, which records repository states and allows you to use JJ undo to safely revert any action. The evolution log tracks how individual changes evolve over time, making it possible to recover previous versions. And another significant improvement in conflict handling, rather than stopping work completely, JJ allows conflicts to exist while you continue working, giving you the freedom to resolve them when convenient. And this is especially interesting here. Any modifications to your file, whether editing, moving, renaming, or deleting, is automatically captured by JJ. So there's no need for a Git commit. That's, I think, very interesting. I have not used JJ yet, but I want to try this on my next occasion. So that's it from my side. If you have used JJ in the past, please tell me your experience. I'm really curious how the experience was. See you next week.